Hi dear friends, I take this opportunity to welcome you for this session, transportation problem, optimal solution. In the previous session, we have discussed about transportation problem, initial basic feasible solution. That is how to find or how to obtain initial basic feasible solution to a transportation problem. This session is continuation to the previous session, in which we are going to obtain or find optimal solution to the transportation problem. Coming to the learning objectives of this session, after this session you should be able to obtain optimal solution for a transportation problem, understand various special cases of a transportation problem. Let us take a numerical. Before that, solution of a problem, transportation problem, involves two stages. That is obtaining IBFS as I stated, then optimal solution. So in the previous session, as I pointed out, so we learnt or we have discussed about how to obtain IBFS, that is initial basic feasible solution, by various methods, namely northwest corner rule, least cost method, and Vogel's approximation method. And then we have concluded that VAM, that is Vogel's approximation method, will give you the best starting solution, which will be very close to the optimum solution, or even in some cases, so the IBFS itself will be the optimal solution. Hence, if it is not mentioned to give any method to obtain IBFS, that is initial basic feasible solution, by default you use the VAM, that is Vogel's approximation method, in obtaining the IBFS. Then you can proceed to find or obtain the optimal solution. A car company has 3 car manufacturing plants at A, B and C, where 2, 6 and 7 truckloads of cars are manufactured respectively. The requirement at its 4 showrooms 1, 2, 3 and 4 are 3, 3, 4 and 5 truckloads of cars. The cost of transportation of 1 truckload of cars from the plants to the showrooms in thousands of rupees is given in the table. Determine the optimum transportation plan that minimizes the total transportation cost to the company, that is car company. Fine. Now let us say there is a car company which is manufacturing cars in South India at 3 locations or 3 plants, A, B and C. So truckloads, 1 load of car. Okay, plant A can produce 2 truckload of cars, B 6, C 7. So what is the total production of the cars? Let us count. That is supply, sigma supply, 2 plus 6, 8, 8 plus 7, 15. So in other words, you are having the capacity or supply of 15 truckloads of cars. Whereas coming to the showrooms, where the cars will be disposed or sold, the company is having 4 showrooms in different locations, 1, 2, 3 and 4, where the requirement of cars is 3, 3, 4 and 5 truckloads. So requirement, some of the requirement or some of the demand, requirement and demand, they are one and the same. Okay, is 3 plus 3 plus 4 plus 5, that is 15. So that is sigma supply is equals to sigma demand. Fine. The cost of transportation of 1 truckload of cars from the plants to the showrooms in thousands of rupees is given below. So this is a plant, this is the showroom. If you want to transport 1 truckload of cars from A to 1, that is from plant A to showroom 1, 15 in thousands it is given. Instead of writing thousands here, it is truncated and written only the numbers and the zeros are truncated. 15,000 it is in fact. Finally you can take that into the account. 10,000, just 3 zeros were skipping here, 17,000, 18,000 uniformly. Okay, you have skipped all the zeros, like 16,000s, 13,000s. Fine. Just okay, if you multiply the whole answer by 1000, no, that will be sufficient instead of having the big numbers in the matrix. Like, okay, let us analyze the problem before attempting it. Fine. Now, so there are 3 plants. Fine. A, B, C. There are 4 showrooms. 1, 2, 3, 4. These are the costs of transportation. Coming to the rim conditions, no, that is supply and demand. 2, 6, 7. Here it is 2. Here it is 6. Here it is 7. And coming to the demands and requirements, here it is 3, 3, 4 and 5. So as I have told, sigma supply is equals to sigma demand, that is summation of this is equal to summation of this, hence it is balanced problem. And as I have told in the previous slide, so it involves 2 stages, because so in the question it is given not to find just initial basic feasible solution, you are supposed to find the optimum transportation cost. In other words, optimal solution you have to find. So to obtain optimal solution, first you have to find initial basic feasible solution, then you have to go for optimal solution. That's what I mentioned, it is 2 stages. Like, fine. IBFS you can find using VAM, no need to find using all the methods. Now let us go to the solution part. The transportation table, okay, so is like this, and sigma supply equals to sigma demand. VAM, that is Vogel's approximation method, as we have discussed in the previous case, no, has been used, and these are the allocations. Like, fine. So you can check 2, 1 plus 4 plus 1, 6. This is 3 plus 4, 7. Okay. In the previous session, VAM was been explained with the animations. Okay, you please refer that. Okay. 3, 2 plus 1, 3, 4, 1 plus 4, 5. Like. So just okay, in 3 steps we have solved, who obtained the IBFS, finding the difference between least and next least, okay, for all the rows, for all the columns, and identifying the highest difference, searching for the least element and allocating as many units as possible for that. Okay, so that was the concept we discussed related to the VAM, and by using the VAM, these are the allocations. Fine. Now, hence VAM can be applied. Why? Sigma supply equal to sigma demand, to find the initial basic feasible solution. The initial basic feasible solution will be just multiplication of this into this, this into this, this into this, and so on. Okay, that is 2 into 10 is 174 thousands, like, because it is given in thousands, no, thousands of rupees, somewhere it is given in the problem. Find this thousands, 174 thousands. Fine. So this is very simple. Okay. So difference between, for example, the first one, no, the difference between least and next least 10, the next list is 15, 5 the difference. So here the least, okay, just I'm explaining the VAM, 13 and 12, the difference is 1, and so on. You have continued for the rows and columns. Out of all these differences, the highest difference is 5, you know. 5 exists here as well as here, but okay, if you take in this direction, the least element was 12, whereas in this element the least element is 10. Hence we preferred this, and we have continued the process. Like, okay, just I'll repeat. So we have obtained first run of explanation is this one. I mean, difference between least and next least, that is 5, 1, 1. This one 3, 3. Least and next least 5 and 2. Out of all these differences, 3 plus 4, 7 differences, the highest difference is not unique, it is repeated, or there is tie, I can say. How to resolve the tie also have discussed very clearly. For example, okay, there is 5 here also, there is 5 here also. This 5 corresponds to this row, this 5 corresponds to this column. When you see in this direction, the least element is 10, whereas if you see, or if you observe in this direction, the least element is 12, like. Okay, as our focus is to obtain the least cost, no, so we have preferred this because there is 10 here. So instead of 2 into 10, okay, if you go for 2 into 12, the cost will be more, no. So that's why we have preferred this location. Fine. This, okay, clearly we have discussed in the previous session itself. Fine. Now this is stage 1, what I can say. Obtaining IBFS is the stage 1. Coming to the optimality check, which is referred as stage 2, no. So to perform, one thing you have to remember here, to obtain IBFS, you have to ensure sigma supply equals to sigma demand. If not, you have to balance it. That, okay, I'll discuss in the next stage. Sigma supply should be equal to sigma demand. So in this case, sigma supply is equals to sigma demand, no? Like that. So to go for second stage, that is optimality check, you have a prime condition. What is it? Prime condition is m plus n minus 1 should be equal to number of allocations. If not, that will become the special case. That's what in the objectives are defined to understand the special cases also. Here also, if sigma supply is not equal to sigma demand, that will become a special case that will address as a a special case and will discuss. Fine. Here also, m plus n minus 1 is not equal to number of allocations means, so that becomes a special case. So just with some additional concept, no, we can resolve that special case or handle the special case. Then for optimality check, this is the prime condition, m plus n minus 1 must be equal to number of allocations, where m is number of rows, n is number of columns. No? So m in this case, number of rows 3, number of columns 4, hence m plus n minus 1, no? M plus n is 3 plus 4 minus 1, that is 6. Number of allocations means the allocations you obtained by VAM. See, 1, 2, 3, 4, 5 and 6. So allocations you made by using the VAM. So when it is balanced, no, m plus n minus 1 is equal to number of allocations, you can proceed. The procedure is like this. Okay, again you can divide this into 2 sub-steps. Computation of the variables u's and v's. For all occupied cells, no, write the mathematical equations. That's what I'm going to discuss here. For all the occupied cells, write the mathematical equations. Let u2 equals to 0 in this case. Why? We'll discuss the variable with more number of or higher number of allocations, and then solving it we get. Okay, so there is a method called as modified distribution method, which is known as MODI or UV method also sometimes, because u and v, they are the variables. No, modified, MODI stands for modified distribution, or also known as UV method. Okay, this method involves the following 2 stages, no, steps in finding the optimal solution of a transportation problem for which an initial basic feasible solution is already obtained. Fine. So now already you have the IBFS with you by VAM. So step 1 is this one. Okay, this should be here in fact. Okay, step 1 is this one. Okay, so you go back to this one. Okay, so use and v's you have to declare. For all occupied cells, first step is for all occupied cells. So how many occupied cells are there? 6 occupied cells are there. You write this equation. So that is, for example, the first occupied cell is this one, u1 plus v2. u1, corresponding u variable plus corresponding v variable, equate it to the cost, not to this number. Please note it. U plus v equals to 10, like that. That is one thing. One equation, mathematical equation. Then u2 plus v2, 13. u2 plus v3, 12. u2 plus v4, 13. Okay, that's what. Okay, it's very clearly given for all occupied cells. For all occupied cells, you please interchange this. This method will go here. The step 1 is here. Okay, so u1 plus v2, u2 plus v2, u2 plus v3, u2 plus v4, u3 plus v1. Okay, all this. Now you have to compute this u's and v's. That's why it's called as UV method. For that, my suggestion is, for example, okay, if you observe this row, no, is having 1 allocation, this row is having 3 allocations, this row 2, even column is also maximum 2 number of allocations you have. So this row, no, is having more number of allocations. More number means it's not this number, numbers. Okay, 1, 2, 3 like. Hence, if you set that variable as 0, so your calculation time or computation time will reduce. So that is the reason, okay, why it is given like this for occupied cells. Equals, let u2 equals to 0, the variable with highest or more number of allocations. Now you have written the equations, no, mathematical equations for all occupied cells. For all occupied cells, you have written the mathematical equations and you have set u2 as 0. Okay, once u2 is 0, see directly you will get. So what are the values you will get? u2 is 0 means v4 is something like v4. Directly you will get some of the values. Fine. u2 is 0 means v4 13 you will get, v3 you will get as 12 directly, then u2, no, u2 is 0, v2 you will get directly as 13. So it's a simple mathematical manipulation. So you will get all the variables. One thing that you have to remember is, you please set a variable, any variable you can set it to 0 for that matter, but preferably if you set a variable having more number of allocations, no, as 0, so your calculation time will relatively reduce. Okay, that's all. Fine. So once if you set u2 as 0, now u2 is in 3 places, see here. So directly you will get v2, v3, v4. So then substituting these values, no, the other values you will get. Okay, they are written here. See, u2 is 0. So then u1, u3, okay, v1, v2, v3, v4 and so on you will get. Just you have to write them here. Okay, afterwards this is stage 1 or step 1, I can say. Step 1. Okay, so all these variables you have obtained. Then coming to the step 2 in this one, optimality. So in step 1, so these equations you have framed to all the occupied cells. In step 2, you have to compute unoccupied cells for all unoccupied cells. No, so you have to compute net cell evaluations. Delta normally we use. Okay, computation of net cell evaluations for all unoccupied cells. Okay, for example, so which is the unoccupied cell in this? First one itself is unoccupied cell, and for that an equation is given. What is that net cell evaluation is? Cij, I mean the respective cost. Ij means ith row, jth column, and corresponding u and v values like Cij minus ui plus vj. For example, let us take the first unoccupied cell. Please note that. So this computation of net cell evaluations you are doing for unoccupied cells. 15, for example, if you take 15, why I am taking 15 is first unoccupied cell. It is nothing but this one only. Okay, this minus summation of this plus this. Okay, you can calculate here itself, but I have given in the form of equation. Next is 17. No? This Cij, this is called Cij. C means cost, Ij means ith row, jth column. So minus u1 plus u3 in this case, like okay, respect to u and v. That's what okay have done here. So this one 17. Please note that it is not for occupied cells, it is for unoccupied cells. For all unoccupied cells you have to compute this. And if you find all these net cell evaluations, I mean these computations Cij minus ui plus vj are greater than or equal to 0, then the solution is optimum. So what is your observation here? All the values, no, 4, 8, 8, 2, 6 and 10, they are all greater than or equal to 0. Hence, whatever the solution you got by IBFS, no, that itself is the optimum solution. So the optimum solution as you have written using IBFS, same thing we are going to get 174,000 of rupees. Okay. So just to summarize, first stage is obtaining IBFS. This is not new to you. Already okay, have used this concept of obtaining or finding IBFS in the previous session itself. Now optimality check, no, just have divided the optimality check or optimality solution to 2 sub-steps. Okay, that is computation of variables u's and v's. For this, okay, you have to write the equations, no, ui plus vj, something like equals to that cost. So many equations. How many allocations you get? So many equations you will get. Why you will set one variable equal to 0 means, see, okay, if you observe mathematically, 1, 2, 3, 1, 2, 3, 4. I mean 3 plus 4, 7 variables will be there, but only will be having 6 equations. 1, 2, 3, 4, 5 and 6. Okay, but you have how many unknowns? 7. 3 u's and 4 v's. But how many equations you have? Only 6. So one variable will set it to 0, preferably the variable having more number of allocations. So I mean once okay, if you set that variable as 0, all other variables you will get very easily. That is step 1. Step 2 is computation of the net cell evaluations. Please note that this is for all unoccupied cells. Okay, once if you all these values, no, Cij minus ui plus vj are greater than or equal to 0, then whatever you got, no, that itself is optimal solution. Like okay, so that's what I have mentioned, that IBFS will give very close. I mean IBFS, initial basic feasible solution by VAM, no, will be very close to optimal solution, and in some cases IBFS obtained by VAM itself is the optimal solution, I told. Okay, what is your observation? It is observed that the initial basic feasible solution obtained by VAM itself is the optimum solution. Okay, now okay, you may get this one. Okay, if not, if there is negative value, what to do? That okay, of course we'll discuss with the next numerical. If any net cell evaluations are negative, select the highest negative cell evaluation and form a loop, closed loop. That will discuss clearly as I said in the okay, next problem. substitute the value of x and modify the allocations and perform optimality check again and repeat until the entire net cell evaluations are greater than or equal to 0. Fine. Now let us see the simple numerical. Fine. Solve the following problem, like in lakhs of rupees or whatever it is, the transportation cost 27433, and these are the supply and demands. Just to check supply, so and demand, it is same 34. Okay, I mean if add this and if add this, sigma supply equals to sigma demand, hence you can proceed. Yes, you can proceed means you can find out IBFS. One checkpoint or one check post for what? To find IBFS by VAM or any method is, so you have to ensure this. If not, okay, you have to balance it, that is one step extra, nothing else. So then you have to go for second stage. This is first stage of solution solving transportation problem. No? Now okay, by using VAM, no, again finding the difference between least and next least and so on. Okay, we'll continue. Fine. These are the allocations you got. Fine. Here 5 into 2, 8 into 1, all these things you got it. Okay, this method is same only. Difference between least and next least for all the rows, for all the columns. Out of all those differences, the highest difference you have chosen. So then in that the least cost. Fine. It is typically VAM only. Sorry, VAM, Vogel's approximation method in obtaining the IBFS. So here you got 80 lakhs. Okay, 80 lakhs is the initial basic. It is not final solution. It is only IBFS. Initial is a feasible solution. It may be optimum or may not be optimum. We'll see. Okay, this is IBFS stage 1. Okay. Now optimality check. For optimality check, what is the checkpoint? I told m plus n minus 1 should be equal to number of allocations. Fine. In this case, it is satisfied. Hence, optimality can be performed. So, using the same concept, no, same see, U's and V's for all step 1, step 2. So, this optimality solution or optimality check, no, is explained in 2 steps. That is UV method or MODI method, I said, modified distribution method or UV method. First step, no, computation of variables. For all occupied cells, form the mathematical equations for all occupied. For example, the first one, let us see. First, U1 plus V1 is equal to 2. That's all. Like this, for all occupied cells, you form the mathematical equations. Fine. Involving U's and V's. And one variable you have to set it 0. Any variable you can set it to 0 as I told. But preferably the variable having more number of allocations if you set it 0. So you can easily get the computation. Why you have to set it to 0 means, as I told, 1, 2, 3, 4, 5, 6 equations are there, but 7 unknowns are there here. Fine. So hence one variable you have to set it to 0. So then coming to the second step, no. So same for all unoccupied cells, no. Unoccupied cell, which is unoccupied cell, first unoccupied cell 7. 7 minus this U and V you got it, no. So 1 plus 6 or something like. Fine. So you have to compute like this. Fine. All this. And what I said is, if all these values, no, are greater than or equal to 0, whatever the solution you got by VAM, that itself is optimum. But here what is happening, you please see, this is 0, 1, minus 3, sorry, 3, minus 2, 6, 7. So what is your observation? It is not positive. Hence the solution is not optimum. In other words, so whatever the IBFS you got by VAM, that is to be modified. That is not optimum. That can be improved further. There is scope for the improvement in reducing the cost. That is the meaning of this. Now, as I explained somewhere here, the point, no, this you will understand now. So, okay, if it is positive, what to do is, sorry, if it is negative, what to do is, where you got that negative? Minus 2, no, for 3. So, for this. So, if you take first unoccupied cell, this one, this one, this one, and this one. This is repeated, of course, this one is this one. So, you got minus 2 here. So, what you can do is, from there, no, you can form the loop, or you have to form the loop. Wherever you got negative, no, here you got negative, no. So, there you try to form the loop. Loop means, okay, when you take the turn, okay, there are some hints in forming the loop. It is a closed loop. It may be rectangle shape or square shape, or even cross loop also it may be sometimes. Fine. So, for example, here you are starting the loop. Okay, while taking the turn, no, there should be allocation. So, for example, you cannot you cannot form the loop like this. So, like this, okay, you take, then you take turn like this, then you can take turn like this. Fine. So, rectangle shape will get. So, here you put x, some x units you are going to allocate. So, wherever the loop is taking turn, there only you have to adjust the x. Okay, here it is x. So if you add x here, you have to subtract x here, minus x. It is plus x, it is minus x. Alternatively, you have to put x and minus x. Why? Because see, you are not having any freedom to modify this supply and demand conditions. You please note, that is not in our hands. Only you can modify the distributions, not even this costs. You are having only the freedom or option of what? Revising or modifying these units which are written in the angle brackets. So you are not supposed to disturb or modify any of these values. Okay, either costs or the rim conditions. Hence, what you will do is, wherever you got negative, from there you take the loop like this. So simple square loop will get in most cases, square or rectangle. You write plus x here, minus x here, plus x here, minus x here. Okay, you may get doubt what to do with this. No. So only at the corners of the loop, what I can say, you have to write alternatively plus and minus x. Fine. Now, if you do that, see, that's what it is written here, shown in the dotted, x minus x plus x minus x. Now, x, okay, this you have to ignore because x cannot be negative or x cannot be 0. If x is 0, there is no point of exercising all this. No. So, you set 8 minus x equal to 0 and 2 minus x equal to 0. 8 minus x equal to 0. What is this 8 minus x? You can see here, this one, nothing else, 8 minus x. Fine. 2 minus x equal to 0. Out of this, no, you select the x as minimum. Okay, if you solve 8 minus x equal to 0, x is 8, here x is 2, minimum is 2 like. Okay. So 8 minus x, 2 minus x, you have to set it to 0. What to do is, you have to substitute the value of x, that is 2. Okay. So you are going to modify the distributions or modify the allocations. Hence it is MODI, modified distribution method. Fine. So now same thing, no, you are rewriting. What to do? What you are doing is, here you are writing x. Okay, here x, no, just you replace x. X is equals to 2. You got it now. Okay, here 2 minus 2, it will be vacated. This is occupied cell. This is vacated cell. 10 plus x, 12 it will become. This is 6 because 8 minus x. So you can check the rim conditions are not altered. Just you shuffled or redistributed the units like this is 5. This is 6. 2 plus 6, 8. 7. 2 plus 12, same thing it is remained. Okay, there is no change in this. Fine. Just you have modified the distributions. Then same one more iteration you have to do it again for all occupied cells. No. Okay, you have to write these equations and one variable you have to set it to 0. The same procedure having u2. Okay, u2 is having or u1, u2 with any variable you can set it to 0. Preferably the variable having more number of allocations, as I said. So again you have to check for unoccupied cells. Is one more iteration, that's all. The concept is same. What is new here is, wherever you got negative value, from there you have formed the closed loop. Okay. So in forming loop, no, there are some instructions or hints. What is that means? So wherever you start the loop, no, you have to terminate there, and to take turn there should be allocation, and you have to adjust the value of x, no, only at the corners. Alternatively, you have to put x and minus x. Fine. So once if you get the value of x, that is the minimum of these two, you have to put or substitute the value of x, then you have to rework. That's all. Same thing only. I mean, this one only is done again. Same thing, but only thing is with new allocations, substituting the value of x, no, you are repeating. And your observation is, see, after this modifications, no, what is happening? You see here, all these values are greater than or equal to 0. Hence, the solution is optimum, we can say. So that's what, okay, by these allocations you obtain the cost once again, 76 lakhs you are going to get. Whereas by using IBFS, what is the cost? 80 lakh. That's what. So initial basic solution is a solution, possible solution, that's all. Whereas by modifying the distributions or by checking for optimality or after optimal solution, so you are going to get 76 lakhs. In other words, you are going to save 4 lakhs to the company. So instead of like this, no, you are suggesting to plan or distribute like this. So then, okay, you can say, or you can put a comment, the solution is optimum. The optimum cost is this much. Okay, I hope you got it. First thing is IBF is the same. Then optimality check, no. So if all these are greater than or equal to 0, fine, well and good. That itself is optimum. If not, what to do? You have to form the loop from the negative. If there are two negative values, sometimes, okay, you may get two negative values. So it's very rare. If at all, okay, if you get two negative values, no, you have to form the loop from the most negative value first. Most negative, highest negative, in other words. Fine. So as okay, how only one negative here, there is no such issue. For example, minus 2, minus 3 if you have got. So from minus 3, no, wherever minus 3 has come, from there you are supposed to form the loop first. That's all. Okay, you please remember when there are more than one negative values. Okay, so it's very rare. If at all if you get, so you have to form the loop, closed loop from the highest negative value. Now let us discuss about some special cases in transportation problem as I have told. So unbalanced problem. Okay, if the summation of supply is not equal to summation of the demand, it is unbalanced. It can be balanced by adding the surplus or shortfall units to a dummy row or dummy column. Fine. Okay, let us see one by one. Unbalanced in the sense, to find IBFS, what I said, okay, it should be balanced problem like. So what may happen sometimes in this case, if you take any problem for that matter, so sigma supply may not be equal to sigma demand. Supply and demand. In this case, you take, for example, 2, 6, 7, 3, 3, 4, 5. So 2, 6, 8, 8 plus 7, 15. This way also 15. If it was 4 or something like 3 plus 3 plus 4, that is 10. 10 plus 4, 14. So 14 means, okay, here it is 15, no? So you have to add accordingly a dummy row or dummy column with all zero costs. All zero costs. That difference of units you have to adjust. That's all. Then it will be balanced. Either row you have to add or a column depending on this difference. No, for example, so this is 15, this is 14, you say. So in that way, so whether to add row or column, automatically you can decide. And please note that the row or column will having only the zeros, and that units, no, you have to adjust to the dummy row. That is called dummy row or dummy column. Okay, let us come back to that. So if summation is not equal to, summation of supply, sigma supply is not equal to sigma demand, you find out the difference. For example, sigma supply is 10, demand is 15. Okay, let us understand in a simple way like this. Sigma supply is 10, supply is 10, demand is 15. Okay, then you have to increase the supply, no? So you have to add the rows. That's all. It's a common, a simple way to analyze. Row you have to add. If supply is less, no? Supply is less. How to increase the supply? You have to add a dummy row. Dummy row means additional capacity you have to initiate or you have to install. Fine. Assume that, okay, supply is more. Supply is 20 units. Demand is only 10 units. Then you have to find out one more place to sell. So in other words, you have to add the column. That's what. Accordingly, you have to adjust the difference of units by adding a dummy row or dummy column. That's all. Okay, that is about the first special case. Then next one is maximization problem. Sometimes, they'll ask you to maximize the profit or so. Of course, transportation means it is minimization only always, but same algorithm. It's very rare. Okay, so theoretical concept it is. Okay, if they ask you to maximize the profit by using the transportation algorithm, so giving some numbers instead of costs, profits if they give something like. So what you have to do is, one step it will be extra, like, the numbers, if they indicate the profits, these numbers, they are not the costs, let us say. So by using the transportation algorithm, you maximize this one, the profit, if it is given. What is one step extra is, if the objective is to maximize the same concept, same algorithm, same concept can be used to solve the problem. In the given matrix, all the elements should be subtracted from the highest element. You select the highest element of that matrix and subtract all other elements from it. For example, if this is to be maximized, highest element is 7. So all other elements, 7 minus 2, 7 minus 7, 7 minus 4, 7 minus 3, 7 minus 3, 7 minus 1, like that. All other elements should be subtracted from highest element. Okay, around the highest element, all other elements you subtract from that highest element. That is second, this one, this one. Prohibited route. Of course, this will discuss in the next, this one. Prohibited means, okay, the special case of transportation. The allocations or assignments should be avoided for such locations forever, designated by dash or m or infinity. What is the meaning of this? Means there may not be route, for example. So here it is given O1 to something like, A to 1. Sometimes they'll give dash or infinity or m. What is the meaning of that is, due to some reasons, so shipment or transportation is not possible from this location to this location. That you have to leave it forever. Okay, infinity or dash you put it. Even in finding the differences also, that will not be affected. I mean, that will not come into the picture, like, got it? So just they'll give dash. Dash means ignore it, that's all. Don't take it into the consideration. That is called prohibited route because of some reasons. So there may not be proper route, or some transportation cost may be high or something like. So in such cases, no, so it is prohibited forever, like nothing else. So that will not come into the picture. That location is left blank forever. Fine. That is the next this one. And the last one, as I told, degenerate transportation problem. Fine. There are 4 special cases. One is unbalanced. No, supply is not equal to demand means okay, that you have to adjust accordingly. So by using or adding dummy row or dummy column, maximization just now explained, prohibited, degenerate. Sometimes m plus n minus 1 may not be equal to what number of allocations. Okay, so m plus n minus 1 may be 5, whereas number of allocations may be 4. So in such cases, what you have to do is you have to introduce a dummy allocation epsilon, which tends to 0. Tends is missing here, which tends to 0, to a least unoccupied cell which does not form the closed loop. That's all. Then the number of allocations will become equal to m plus n minus 1. Okay, this okay, I'll explain through a numerical, I mean through an example. Okay, what will happen here is m plus n minus 1 is not equal to number of allocations. Then you cannot proceed for the optimality. That is second stage you cannot perform. In that case, what you have to do is you have to introduce okay a dummy allocation, that is epsilon, which tends to 0. But where to introduce is the question here. To a least unoccupied cell which does not form the loop. Okay, closed loop you should not form. In such a way, no, you have to introduce the epsilon. For example, if the least unoccupied cell is forming the loop, no, then you go for next least. That's all. That okay. So just you can see here. Assume that okay here you are getting this one. M plus n minus 1 is not equal to number of allocations. M plus n minus 1 is different and number of allocations is different. Fine. Then in this, no, you have to find out the least unoccupied cell. For example, this one, let us say least unoccupied cell. So okay, you have to put epsilon, that's all for that, so that number of allocations will become equal to m plus n minus 1. Okay, so it will not form the loop, I am sure, but if at all if it is forming the loop, no, next list you have to see. See, loop means if you put epsilon here, it should not form the loop in any direction. Okay, so it will not form. Okay, so like this or like this. Okay, check it. Epsilon you have to introduce or you have to put to a least unoccupied cell which will not form the closed loop. Okay, that is whenever you observe this condition. It's very rare. Okay, so but of course, as it is a special case, you have to understand the theoretical concept, and even okay, if you get a situation like this in problem, you should be in a position to tackle. Fine. M plus n minus 1 is equal to 6. Number of allocations 5. No, then okay, what will happen? Okay, if you proceed also, you will struck. Okay, you will struck. Why? So variables okay will be more, whereas equations will be less. Number of equations will get less. So hence you cannot solve or you cannot proceed further. So to resolve that, in the beginning itself you put a dummy allocation for a least unoccupied cell which will not form the closed loop. See what will happen. For example, if number of allocations are 4, no, only 4 equations you will get, whereas number of this one will be okay more variables. Hence you cannot solve. You cannot set 2 variables 0. No, 1 variable only maximum you can set it to 0, just to avoid all these complications in the later stage. So in the beginning itself you have to check this m plus n, whether m plus n minus 1 equal to number of allocations or not. Okay, if it is done, I mean if it is satisfied, fine, no issues. Okay, if it is not satisfied, then only you have to go for this one. Okay, that's what is discussed here. That's what degenerate transportation problem. If m plus n minus 1 is not equal to number of allocations, then it is okay degenerate transportation problem. Okay, introduce a dummy allocation epsilon tends to 0 to a least unoccupied, so that number of allocations will be equal to m plus n minus 1. You can proceed as usual. Now let us take a simple case study or realistic problem where you can apply this concept of transportation. The following table shows all the necessary information and the available supply to each warehouse. Requirement of each market and unit transportation cost from each warehouse to the market is given. Okay, fine. Warehouse to market. A shipping clerk has worked out the following schedule from his experience. 12 units from so and so, 1 unit, all this okay is given. Check and verify if the clerk has the optimal schedule. So this is quite different. Okay, so of course these are the transportation costs. There is a clerk okay in a transportation company, let us say, by his experience is working out to ship so many units from warehouse to the market. That is given 12 units from A to 2. I mean here it is 12. 1 unit from A to 3. okay, here it is 1, like that, okay. So he has given some allocations, or he has made some allocations, fine. Then you have to check whether the clerk has optimal schedule or not. Okay, for this what to do is, okay, in other words, indirectly initial basic feasible solution is given, like you can say that, so 12 units from A to 2 it is given, 1 unit. So you can add all this and you can write the supply and demand conditions also. Finally, you have to go check for optimality, that is using UV or MODI method, just now we discussed, no? You check. If all these values, no, the net cell evaluations are greater than or equal to 0, then you can say that the clerk is having optimal solution. If not, you can improve the solution or you can save the cost. How much you can save and all you can see. Okay. So that's what. Okay, shipping clerk, no need to find IBFS once again. No need to find initial basic feasible solution for this problem. So why? Already some initial allocations or some allocations, okay, are given. Just you are given to check or verify whether it is optimum or not. I mean, stage 1 is given to you, stage 2 you have to check. I mean, optimality check you have to do, or in other words, you have to find the optimal solution using UV or MODI method. Fine. Now why I have given this means, okay, so that you will come to know in what way it is effective. So how much amount you can save. So what is the difference between clerk and a person who knows the optimization or an engineer? Fine. Like that. Fine. 12 units from A to 2, 1 unit from A to 3. All this is doing by his past experience. So what is your this one opinion, or what is your observation? Check whether the optimum solution is following or not, optimum distribution is following or not. That's what is this case study. Fine. You please check. So just by using this 12, all these things, so definitely it is not optimum, and okay, you can improve the solution and you can save some cost to the company by following the optimal schedule. Fine. Let us come back to the objectives. I hope certainly you have met the objectives that we have listed, objectives or outcomes. Now we are in a position to obtain the optimal solution, that is stage 2. Stage 1 is IBFS, stage 2 is optimal solution. We have discussed the various special cases of a transportation problem, right from unbalanced, next one is maximization, prohibited route, then finally we have discussed degenerate transportation problem. Fine. So I take this opportunity to thank you one and all. Have a nice time. Take care.